Hello everyone. Today we will discuss about Huffman coding. So what is Huffman coding? So it is a data compression technique. It is used for reducing the size of the data or message. So when any data is sent over network, it can be reduced or compressed so that the total cost of transmission can be reduced. This technique is lossless. It means we can send the data without losing any information. So in this algorithm, we assign a variable length code to each and every character of the input, and that code will depends upon the frequency of the character. So the most frequent character will get the smallest code, and the character which is appearing less frequently will get the longer code. So in this video, I will explain you if a normal message is sent, then what will be the cost, and what is the fixed size encoding and what is the variable size encoding. So now suppose I have this message and I want to send this message over the network. So now we will calculate what is the size of the message. Means how much size it will take to transmit it over the network. So the size of the message is measured in terms of bits. So here we have 20 characters in the message, and each character will be converted into ASCII format. So each ASCII character has 8 bits. So all the electronic devices and computer uses ASCII codes for any character, and each ASCII code is of 8-bit long, and we have here 20 characters, and these characters are from A to E. So we will see what is the ASCII code for A. So ASCII code for A is 65, and we represent that in a 8-bit format like this. Then ASCII code for B is 66, and we represent it in 8-bit format like this. Similarly, we will have ASCII code for C, D, and E. And so now we have 20 characters in the message. Each character will get 8 bits of ASCII code. So the total bits we will require will be 20 cross 8, that is 160 bit. So to send this message over the network, we will require 160 bits, and that is without encoding. So we are using a standard ASCII code to translate this message into bits, and we will require 160 bits if we go without encoding. Now we will see what is fixed size encoding. So instead of assigning 8 bits to each and every character, we can have our own code, and we will assign that code to each and every character. So we have to decide what code we are going to use for each and every character. So for that I have formed a table. So here I have characters from A to E which is appearing in this message, and this shows the frequency of this character. So A is appearing 3 times in this message, B is appearing 5 times, and now we have to decide what code we are going to use for each and every character. So now suppose if I get only 1 bit, so I can represent that 1 bit either in 0 or 1. So I can represent that 1 bit only in two format. Now suppose if I get 2 bits, then I can form a different combination using 2 bits. So the combination could be 0 0 0 1 1 0 1 1. So using 2 bits I can form 4 different combination. So I can assign 4 different characters to each and every combination. But here I have 5 characters. So we will take 3 bits for each and every character. So using 3 bits, I can form 8 different combination, and out of 8 combination, I will use 5 combination for this character. So suppose I am assigning A as 0 0 0, B as 0 0 1, C 0 1 0, D 0 1 1, and E 1 1 0. So instead of 8-bit ASCII character, I have assigned only 3 bits to each and every character. So now we will calculate the size of this message. So each character is getting 3 bits. Total character in the message is 20. So the size of the message will be 20 cross 3, that is 60. But we have to consider one more thing here, is that we have assigned our own code to each and every character. So we will need this table at the receiver end so that we can decode this message. So we have to send this table along with this message on the network so that at the receiver end we can use this table to decode the message. So now we have to calculate the size of this table as well. So in this table we have these 5 characters and we have to send this character in a standard format, that is the ASCII format. So each character will get 8 bits. We have 5 character. So the total size will be 5 cross 8, that is 40. And now we have to send these codes as well. So each code is 3-bit long. We have 5 characters. So the total size of the codes will be 15. So the total, so now the total size that we are going to send over the network will be 60 plus 40 plus 15, that is 115. So the total cost will be 115 bits. So earlier without encoding we were getting 160 bits, and with fixed size encoding we are getting 115 bits. So we have reduced the size of the bits that we are going to send over the network. So this was the fixed size encoding. Now we will see what is the variable size encoding, that is the Huffman coding. So Huffman says that instead of assigning fixed size code to each and every character, we can assign variable length code to each and every character. So Huffman says that the character which is appearing most in the message, if we assign less bits to that particular character, then the size of the message will be further reduced. So now we will see how we can generate our own variable size codes for each and every character. So Huffman uses optimal merge pattern to generate the codes. So using optimal merge pattern, we will arrange this character in the increasing order of their frequency. So here I have arranged these characters in the increasing order of their frequency. So E is at the first place because the frequency is less, and C is at the last because the frequency is more. Now using the optimal merge pattern, we will merge these characters or these frequencies. So we will start with the two list numbers. So here 2 and 3 is the list number. So we'll merge these two numbers to form a node. So here we have merged 2 and 3 and we got the 5 as the node. Now again we will choose the two minimum number. So either we can choose this 4 and 5 or this 4 and 5. So I'll choose this 4 and 5. So I have merged it to form another node, and that is 9. Now out of 9, 5 and 6, the two smallest number is 5 and 6, so we'll merge it. Now we got 9 and 11. Now we'll merge it to form a root. So this is called optimal merge tree. Now using this tree, we can generate our code. So how we will generate it? We will assign 0 to the left edges and we will assign 1 to all the right edges. So I have assigned 0 to all the left edges and 1 to all the right edges. Now using this tree, we can get our code for each and every character. So start with A. So for A, we will follow the path from root. So 0, 0, 1. So this is the code for A. For B, it is 1, 0. For C, it is 1, 1. For D, it will be 0, 1. And for E, it will be 0, 0, 0. So now you can see the most frequent character got only 2 bits and the least frequent character got 3 bits. So now we will calculate how much size this message will have. So A is appearing 3 times in the message and each A will get 3 bit. So the total will be 9. For B, uh, B is appearing 5 times and each B is will get 2 bits, so 5 cross 2 10. Then for C, C is appearing 6 times and each C will get 2 bits, so it is 6 cross 2 12. D is appearing 4 times and each D is getting 2 bits, so 4 cross 2 8. And E is appearing 2 times and each E will get 3 bits, so 2 cross 3 6. Total is 45. So the size of the message is 45. But along with this message we have to send this table as well, so that it will help to decode this message at the receiver end. So we have to send this character as is in the standard format, that is the ASCII format. So the ASCII for each and every character will be 8-bit long. So we have 5 characters. So the total size for this character will be 5 cross 8, that is 40. So this will require 40 bits. Now to send the codes, we have variable length codes. So the total bit it will require will be 1 2 3 4 5 6 7 8 9 10 11 12. So we will require 12 bits to send these codes. So the total size for this table will be 40 plus 12, that is 52, and the total size for the overall message along with this one and the table will get 97 bits. So we will require 97 bits to send this message along with the table across the network using the variable size encoding. And earlier without encoding we were getting 160 bits. With fixed size encoding we were getting 115 bits, and with variable size encoding we are getting 97 bits. So this is the optimal procedure to encode any message, because it reduces the size of the message as compared to fixed size encoding. So that was all about Huffman coding. Thank you for watching.